Okay, so this is Unit 1, exploring one variable data and collecting data. This is going over two topics. So before, this used to be two separate notes, and they went ahead and combined it into one notes. Again, remember, this course, especially Unit 1, is super vocab heavy. So starting off, we have statistics is the study of, any guesses? Data. Data are observations that are measured, recorded, collected, analyzed, and reported for use. Okay, so reminder, I do highlight a lot. You do have highlighters in the pink basket if you want to use mine, or you're more than welcome to use your own. Data contains information about a group of individuals. An individual is an object described by a set of data. The information is organized using variables. Okay. So it says, what is a statistical study? A statistical study is a study in which data are collected from a sample to answer an investigative question about a larger population. So when you do a study, it is not easy to be able to get a representation of every single individual in the population. For example, if I was to ask you to survey every individual in the United States, how long do you think that would take? Forever. That's a great answer. Forever. It would take forever. So a better way to do that is to get a sample of the population, which is the United States. So an example of a sample could be what? Instead of all the U.S., we just collect data from one state. Okay? Even smaller sample from that, instead of collecting it from the state, we could collect it from one city or town. Okay? So a sample versus a population. So again, a sample is a smaller group that you collect data from. The size of a sample is represented by lowercase n. And a value that describes a sample is called a statistic. Okay, notice statistic and sample both start with the letter S. So if I ask you a value that describes a sample, you will say statistic. This is a common question on the tests. Okay, for population, this is now the entire group, not just a small group, the entire group that you're interested in learning about. The size of a population is denoted by capital N. And the value that describes a population is called a parameter. What do you notice about those two words? They both start with the letter P. So parameter, population, statistic, sample. Pretty easy to memorize. Okay, so that leads us to why a sample? Why are we taking a sample? Well, we already mentioned that if we were trying to survey an entire population, that would take way too much time. Okay, that is too large to be able to sample every single person, and it's also very expensive. So imagine how much time it would take to sample everybody. There has to be a person that you're paying to do that. Okay, so that is too expensive for us to do. That's why we only do it every couple years, and it's called a what? A census. Okay, so it says, why would we not survey every high school student in the U.S.? What would be one reason? There's too many, so it would take too much time. So take too long / too much time. So it says, if we wanted information on every high school student in the U.S., what is the next best thing that we could do? So instead of every U.S. high school student, we could do what? So like only one state? Every high school in that one state? One high school in every state? Okay. So what's the difference between looking at all the high schools in one state versus looking at one high school in every state? The curriculum might be different. There might be differences between the high schools. So if we get one from each state, we're getting a better representation of our total population versus if we just looked at all high schools in Texas, we're only getting a good representation of what? Texas. So we could sample one high school from every state. That would be one way we could do that. Okay, any questions so far? Difference between a sample and a population? Okay, we're going to look at an example. So in this example, it wants us to identify the population, the parameter, the sample, and the statistic. So in our example, number 1, it says the average height for a 15-year-old female at our high school is 5'4". A sample of 10 females at our school has an average height of 5'7". So the first thing we're going to identify is the population. So what is the entirety that we're looking at first? Good. 15-year-old females where? At our high school. So if it says our or the, then you have to make sure you emphasize that. Okay. Even better, if it gives us the name of the high school, then we would write the name of the high school. Okay, so a population is all 15-year-old females at our high school. Okay, what would be the parameter that's attached to that population? 5'4". Remember, the parameter is the data that's attached to a population. So they said the average height for all 15-year-old females at our high school is 5'4". Okay, now we're looking at the sample. What sample did they take? 10. 10 what? 10 dogs? 10 females? 10, you think 10 females of any age? Or do you think they did 10 females that were 15 years old? Okay, so 10 15-year-old females. Where? Anywhere in the world? In our high school. Okay, and then lastly, the statistic. What statistic is going to be related to our sample? 5'7". And again, I color code it. I like to color code. You don't have to. If you like to, you can. Okay, so notice how when you guys were defining population and sample, I was making sure you were going to be as specific as possible. So if they have any type of adjectives in there describing, for example, female, we have to include 15-year-old. Okay. So go ahead and take 2 minutes and do number 2 with your group. And then I will call on 4 random people to answer. Or let's do it this way so I don't say people's names out loud. I will just call on a group, and that group has to answer. So you should be talking, highlighting, discussing, comparing. Okay, and I'll know when you're done when your pencils are down. Okay, let's go ahead and start with group 5. What is the population?
All the high school students in the county.
Perfect. So all high school students in our county. That's how they described it, so that's how we're going to write it. Okay, group 1, what is the parameter for that population? Good, 18 hours per week. Okay, group 3, what is the sample? Perfect, so 50 high school students in our county. So instead of sending out a survey to every single high school student in our county, we picked 50 of them. And then group 4, what is the statistic? 23 hours per week. Okay, perfect. So this is a common question. I believe there is a question like this on your homework. You have to be able to identify these 4 things. Any questions? Okay, so let's go ahead and learn more vocab. So we have 2 words. We have datum and we have data. So datum, this is actually new for this CED, for this course, is a single piece of information. So it's a one value from an observational unit. So for example, if I was to ask someone randomly in here what they got on their last test, the answer that they would give me would be called a datum. Okay, one individual piece of data. Okay, data is a collection of data values or a collection of individual datums. Okay, so data is the plural word for datum. Okay, so for example, if I was to ask all of you guys your last test scores and you guys all each gave me individual datums, your collective answer would be data. Okay. Then we have an observational unit. And this is an item or individual from which a datum is collected. So item or individual for which datum is collected. So in this example, they say, let's say I gave you all the test scores from Unit 1 from last year. Okay. The observational unit would be each individual student. Okay. The datum would be the test score for each individual student. Okay, so the observational unit is each individual person. They are the person that took the test and got that single test score. Okay, and that leads us to investigative questions. So this is also something more defined this year, is they want you to be able to identify a good investigative question. So an investigative question should have a clear, defined purpose. It should be decided before you collect any data. And it should not be changed based on the results that you get. Okay, so what do you think this sounds like? And a hypothesis. Good. An investigative question is a type of hypothesis. So when you defined your hypothesis, once you collect your data, if your data is not proving the conclusion you wanted, do you go back and change your hypothesis? No. So that's what they're saying. You don't go back and change based on any results you get. If you want to have a strong investigative question, so this is what's going to give you that A, that 100, a strong investigative question, you need to make sure that it identifies the population and it identifies the variable, and that the variable is clear and measurable. Okay, so there's no guessing on what that variable is. We can clearly find it within the statement and identify it. Measurable means we can collect data from it. Okay, and then it has to be answered with collected data. So you can't just answer an investigative question if you have no data to back it up. Okay, just like you can't prove or disprove a hypothesis without doing the same. So it gives us two examples here. It gives us an example of a good one and a bad one. So let's start with the bad one. So a bad investigative question. Notice the question says, do teens sleep enough? Okay, so some people say no. Last class, some people said yes. But is sleep enough measurable? Or is it more of an opinion? An opinion. So if some people can say, well, I sleep 5 hours, that's plenty. Others may say, no, I need my full 10. Okay, so that's not measurable. We're not able to distinctly give a value here because enough is subjective. Okay, versus a good one. This one says, what is the average number of hours of sleep per night for the 12th grade students at North High School? Notice it identifies a population. What's the population? At North High School, that's the population. What's the variable? Average number of hours of sleep per night. Was it easy to find the variable? Yes, that means it's clear. And can we measure this? Can we go and ask individuals on average how long they sleep, and do we get a numerical value back? Yes. Okay, so it's measurable. Okay. The next important thing is we need to make sure that we always answer any questions in context. Okay, for example, if I was to answer a question and state the mean is 6.2, do you think that includes context or does not include context? Does not. So this is not in context. Because 6.2 what? 6.2 hours, 6.2 shoe size, 6.2 height, we don't know. Okay. Okay, now look at the next one. It says the mean number of hours of sleep for the sample of seniors is 6.2 hours. Is this in context? Yes, we know exactly what this number, 6.2, is representing and what population it came from. Okay. So this is where statistics will differ, because any other math class, if you just were to put 6.2, most likely you get it correct. They don't need anything else. They just need that number. In stats, every single answer you write will be in a sentence. Okay, you will write a lot in this class. Everything you answer is a sentence or a paragraph. Okay. And that brings us to two types of variables that we're going to talk about today. And these two types of variables are categorical and quantitative. Okay, so again, a variable is a characteristic that may change from one observational unit to another. So, for example, if I was to ask you guys all your favorite color, would you guys all say the same color? No, okay? It would all be different. It would all vary from one observational unit. Okay, the first one, categorical, is data that is placed into specific groups, or in other words, categories. So an example of that would be the example I just gave, favorite color. This means that your data that you're collecting is not necessarily a number. Okay? It could be an object that have different answers within it. So color can have different answers, blue, green, red, purple, etc. Okay, group 1. What would be another example of categorical? Favorite animal, that works. Okay, group 2, another example. Favorite food. Good, because if you were to ask someone their favorite food, would they say 6.2? No, they would give you an actual object or category. Okay, group 3, another example. Hobbies. Okay, so favorite hobby. Okay, what about political party? Just giving you some examples that are on my key. But you guys gave beautiful examples, but I just want you to think of examples like political party. If you were to ask someone that, would they say 6.2? No, they will give you a name of a political party. Yep, where they graduated from. Yep, that would be another good one. Some more examples on this key are shirt size. So small, medium, large. Grades, but grades like A, B, C, D. Okay, now we have the next variable, which is quantitative. And so if categorical is objects, quantitative is what? Numbers. Okay, so quantitative is numbers. So since we have two types of numbers, we have two types of quantitative data, that is discrete and continuous. Discrete and continuous. So if you were asked to identify a variable and you said the variable was quantitative, meaning it had a numerical value, you would have to then put it in the category of discrete or continuous. So discrete is whole numbers. So if I was to ask you to count to 10, how would you count to 10? Good. Did any of you go 1.1, 1.12, 1.13? No. So it's whole numbers. It's things that you can count. Okay, things that you can count. So let's see, group 4. What's an example of something you can count? Okay, number of apples. Group 5. Any other examples of something we can count? Students, so number of students. Okay, what about number of siblings? If I was to ask you how many siblings you have, would you say 1.5? I hope not. Right? We can't have 0.5 of a person. Okay, so if discrete is counting numbers, what's continuous? Decimal. So discrete, continuous, and good decimals. So what would be an example? Group 6. Okay, so that's a good point to bring up. So I want you to write special case under discrete, and I want you to put shoe size. So shoe size is considered discrete because there's only one way to describe a shoe as a decimal, and that's what? 0.5. Okay, so you're either a size 6 or a 6.5. A 7, a 7.5. Do you go into a store and say, do you have a 7.459? No. Okay, so that is a special case where shoe size is actually discrete. Okay, any other examples that you can think of that's continuous? Height. That's a great example, height. Because when you describe your height, do you just say your whole number of feet? Do you say you're just 5 feet? No, you say I'm 5'4", 5'6", etc. Okay, so height. Okay, group 1, any other examples that are continuous? Think of things that you don't describe as only whole numbers. Money works. Grade, I mean, typically when you see a grade, it is rounded to a whole number. So that'd be an example of a discrete. Time, yes, that was the one I was going to bring up, time, because when we say the time, do we only say the hour? No, we say the hour, the minute, the second, all the way down to sometimes the millisecond. GPA. So when you guys do your ranking, is the GPA like mini decimals? Then GPA would count. GPA would count. Okay, so just because a number does not automatically make it quantitative, can you think of an example of a number that is categorical? And an example is zip code. I don't want to age. So if I was to ask teenagers their age, okay, so right now you would say your age is probably 16, 17, 18, okay? Would you ever go up to someone when they ask you your age and say, I'm 16.4? No. However, if you go up to a 3-year-old, is it more likely that a 3-year-old is going to say that they're what? Or 3.5, right? They're going to go, I'm 3.5, I'm 3.25, I'm 3 3/4, because they're super excited to change that next age, right? So when we see age, we want to make sure we treat it like a discrete variable, because people can say, sure, 16.4. But if you have to think of a normal conversation, you're meeting someone for the very first time, you are not going to go up to them and say, I'm 16.4 years old. They're probably not going to talk to you again. They're like, okay, you're a little strange. Okay, so what I want you guys to do now is I want you to answer this question. So we have a scenario and you have all these things you want to answer. This is a great example of what a test question will look like. Okay.